Hello everyone. In this video I am going to demonstrate amplitude modulation and demodulation. I will be using a ring modulator for amplitude modulation and I will be using envelope detector for demodulation. So as you can see, this is my setup. This is a very basic setup for amplitude modulation. For the carrier frequency, I am using 555 timer IC. As you can see here, I am using 555 timer IC. This oscillator is generating a frequency of 48 kilohertz. So for the modulation purpose, I am using a ring modulator. I am using a diode ring modulator. So as you can see here, the ring modulator is lying below. You can see a bridge rectifier below. See, these are the diodes 1, 2, 3 and 4. So these 4 diodes consist of the ring modulator. You can see a closer view. Now the view is a bit closer. You can see there are 4 diodes, this one, this and this. So these 4 diodes, they consist of the ring modulator. So the diodes are, I am using Schottky diodes for the purpose. So these are the high frequency diodes. That's why I am using Schottky diodes, so that the waveform is not clipped off. So as you can see here, 48 kilohertz signal is generated and it is fed to this ring modulator. Also, the modulating signal from the oscillator is fed to this ring modulator. The complete modulation is taking place here and the output is fed to this envelope detector. You can see here, this is the envelope detector. You can see this is a diode, high frequency diode, and there is a capacitor below with a 10k resistance, 20k resistance actually. So it is forming the demodulator. The output of the demodulator is fed to this capacitor, small capacitor, and it is fed to this speaker. So whatever signal we are feeding, we are expecting to get back the same signal. So let us look into the circuit diagram. So as you can see, this is my circuit diagram. So this is the basic ring modulator. This modulator is responsible for mixing a high frequency signal and a low frequency signal, and we will be getting some waveform, and the waveform will be demodulated by this demodulator. So as you can see here, this is the A cos omega ct. This is the carrier frequency. So here I am not using a sine wave, I am using a square wave, and here also modulating signal is also a square wave. So I am feeding a carrier frequency here, you can see at this point, and I will be feeding modulating signal, low frequency modulating signal here. So I will be using a capacitor because because this circuit has a different impedance. So only the AC component I want to push in. I don't want to push any high frequency component back here. That's why I am using this capacitor, so that there is a coupling difference. So that's why this is a coupling capacitor. Without this coupling capacitor, we should not connect low frequency signal here. So this is the setup. So after this setup, you can see from here I am getting the modulated signal and it is fed to this demodulator, and from the demodulator I am getting the final signal. So let us look into the waveform. So as you can see here, I have made the waveform dynamic. So you can see here the carrier frequency is here with the waveform. Just a minute. You can see here this is the modulated signal. Okay, after modulation, this is the modulated signal. You can see carrier is present here. That's why the green mark is very deep. And after the demodulation, you can see this is the waveform. So if I zoom the waveform further, you can see, let me zoom the waveform little more. You can see the presence of carrier. You can see here is the carrier. You can see. So I will zoom it further. You can see. So this is the waveform. So if I stop the oscilloscope, I have put the oscilloscope on hold, you can see. So this is the waveform. See, this is the modulated signal, and here is the, after the demodulation, this is the output. You can see this is the output after the demodulation, after the envelope detector. If we bring both the signals together, what we will see, you can see. So this is the, you can see. So this is the amplitude modulation happening, and after the amplitude modulation, when we are demodulating, we are getting back the original signal. So let us hear we will try to hear the waveform, because the amplitude is very low. The sound will be very poor, but still we will try to hear the sound from the speaker. So this is my speaker. You can hear the sound. Let me bring the speaker near to the phone because amplitude is very low. That's why the sound is not very audible. I need to amplify, put amplifier and get this sound back. You can hear, I guess. You can hear some sound. So this is the sound from the speaker. Let me change the frequency. The sound will change. You can see. You can see the sound pitch is changing. Can you hear? So this is how we are getting back the whatever signal we are feeding, we are getting it back here at the demodulator, and we are getting it back at the demodulator, and we are hearing it on the speaker. Can you hear? So this is how amplitude modulation, basic amplitude modulation works. In the next video, I am going to put real voice signal and we will see the response of this circuit. Thanks a lot. Thanks for watching.